Okay, this is part two of section 1.3. Now, the reason why I broke this up into two sections is because these last three problems are uh, the more, they can be tricky. They're a little bit more involved. They're not difficult, but they're just a little bit more involved, and they involve some critical thinking as you work through these. Okay, so let's look at number 5. It says Richard has a total of $1,800 borrowed from two different sources. The high maintenance source, his mom, charges 1.5% interest plus mandatory Sunday dinners, and the other source charges 4% interest. After 1 year, Richard has paid a total of $42 in interest. How much did he borrow from each source? Okay, so there's a lot of information going on. So he's borrowed some money from two different sources, and each source is charging a different interest rate. And then it says after 1 year that he paid a total of $42 in interest. Now, that is where you are going to get your verbal model from. So after 1 year, he paid a total of $42 in interest. Now, he paid a total of $42 from two different sources, right? Okay, so what are our sources? Well, he borrowed some money from his mom, and then we have this other source. So we're just going to say that mom is going to be something, and then the other source is going to be something else. Okay. So our verbal model, since we're talking about interest, the verbal model is going to be, let me make sure I want to be consistent. Yep. Okay, so I'm going to do this in purple. Okay, so we're going to have the interest from mom plus the interest from the other source. Other source. And we know that the total in interest is $42. Okay, now we need to figure out how are we going to set up our unknowns? What are we going to look for? Okay, well, let's think about this for a second, and then we'll deal with the interest part in a minute. So he borrowed $18 from two different sources. So let's think about this. If he borrows $800 from one source, then that means, and it doesn't matter who, okay? If he borrows $800 from one source, that means he had to borrow $1,000 from the other source. If he borrowed $600 from one source, then how much did he have to borrow from the other one? And you should say $1,200, right? Because 1,200 plus 600 totals $1,800. Now, the way we do this, since it's not specifying which one he borrowed the most from, all we're going to do, and think about this for a second, however much he borrows from one, you're just going to subtract that amount from the 1,800, and that's going to give you the difference. Okay. So let's, again, for no reason at all, because it didn't specify who he borrowed the most from, we're just going to say that he borrowed so much money from mom. So that's X. Now, the other source means however much he borrowed from mom, we're going to subtract it from the 1,800. Okay, so the other source is going to be 1,800 minus X. Now, let's go back to what I was saying earlier. If he borrowed $500 from mom, then 1,800 minus 500 would be 1,300. So 1,300 plus the 500 gives us the $1,800. If he borrowed $900 from mom, well, 1,800 minus 900 is $900. Okay, so that's how we set this up. There's no rhyme or reason as to who you're going to assign the single variable to. The key is that you subtract whatever X is, you're going to subtract it from $1,800. Now, this is going to be referred to as our principal. Now, here's the other part that you have to remember. Okay, our simple interest formula is going to be I equals PRT. I is the interest. P is going to be the principal, which is how much you're borrowing. Okay. So how much? R is your interest rate. But your interest rate is going to be as a decimal, not the percentage. Okay. And then T is going to be the time in years. Now, do we have something to plug in for the principal? We do. That's this part. Right, P. Should have left more room. Okay, this is the principal. Now, we have the rate. We have mom's rate. She charges 1.5% interest. The other source charges 4% interest. And then we also have after 1 year, so we know that time is going to be 1 year. Okay, so this formula, I equals PRT, I equals PRT. The PRT is what we're going to be plugging in here. Okay, so we're going to plug in PRT, the interest from mom, and then the PRT, the interest from the other source. That has to total 42. All right, now here we go. P, this is mom, the interest for mom. The interest is going to be X. The rate from mom is 1.5%, but we have to turn this into a decimal, so 1.5%. We move it 2 places to the left, so that's 0.015. And then time is just 1 because it's 1 year. Now, for the other interest, our principal is going to be 1,800 minus X. The rate, the interest rate from the other source is 4%. So 2 places to the left is going to be 0.04. And then time is 1. And that has to total 42. Now notice how both of them are being multiplied by 1, right? So that really doesn't have any effect on anything. Anything times 1 is itself. So we don't really have to worry about the 1. So now here's our equation. So we want to be very careful. So we've got 0.015 times X plus, now we have to be careful here. Now 0.04 times 1 is just 0.04. So we're going to have to distribute. So we have 0.0, pull the calculator up and hopefully you'll be able to see. This will be on the video, but if not, I'm going to walk you through. So I'm going to multiply 0.04. I'm going to distribute to the 1800 times 1800, and that gives us 72 minus, and then 0.04 times x is just that, 0.04x equals 42. Okay, so now we combine our like terms. So I have 0.015x, 0.015 minus 0.04. That gives us negative 0.025 plus 72 equals 42. Oops, x. Forgot the x. Okay, now don't panic because we end up with this negative number. Just follow this through. Now we need to move the 72 to the other side. So 42 minus 72 is negative 30. And this is why I'm telling you, don't panic, because look at what we've got. If we have negatives on both sides, we're going to have to divide by 0.025. Okay, so we're going to take negative 30, and then we're going to divide it by negative 0.025. So negative divided by negative is a positive. So we get x to be 1200. Now, who did we say x was? X belonged to mom. Okay, so that means that we have that he borrowed $1,200 from mom. Okay, now for the other source, whoops, let me get rid of if this is showing. Now from the other source, it's $1,800 minus X, which was the 1,200. So 1,800 minus 1,200 is going to give us 600. So he borrowed $600 from the other source. Okay. And then again, how do you know that we're right? Well, add these up. 1,200 plus 600 gives us 1,800. Okay. Now this one was involved. Okay. And sorry to be the bearer of bad news, but I would not be surprised if you have a question like this on an upcoming quiz or a question like this on the test. So I would definitely make sure that you know how to set up this type of problem. Okay. All right. Now, the next type of equation that we look at is called a mixture problem. Okay, so let's read through this. It says a dietitian needs to mix 10 gallons of milk that is 2.5% milk fat for patients at a rehab home. She has some milk that is 4% milk fat and some that is 1.5% milk fat. How much of each should she use? Okay, we call these mixture problems mixture because we are going to be mixing two or more. But in this case, we're going to be mixing two types of milk fat or two types of milk. Okay, now the first sentence is where we're going to get our verbal model from. Okay, it says a dietitian needs to mix 10 gallons of milk that is 2.5% milk fat. That's what they want. Okay, so that means here's our mixture. We're going to mix this whatever this is, whatever plus whatever this is, gives us our mixture. This is the mixture. And this is going to be the 2.5% milk fat. And how much of the 2.5% do we want? We want 10 gallons. Okay. Okay. Now that we know that, and actually the picture has already set up our verbal model for us. Okay. Now it says she has some milk that is 4% milk fat and some milk that is 1.5% milk fat. Okay. So this one looks like it's more. So we'll say this is the 4% milk fat, and this is going to be the 1.5% milk fat. Now, did they tell us how much of the 4% we need and how much of the 1.5% that we need? And they did not. Now, if you'll look back at the problem we just did, it's the same idea right here. They just told us that Richard borrowed $1,800. They didn't specify how much from each source he borrowed. So we're going to do the same thing. Okay. Now, all I know is that total, I need 10 gallons. And it doesn't matter who you start with to be the single variable. So if I say I'm going to borrow X gallons, let me scoot this over. If I'm going to use X gallons of the 4% milk fat, then how many gallons am I going to need of the 1.5% milk fat? Well, that means I'm going to subtract it from the 10. So this is going to be 10 minus X gallons. Okay. Now, you might be thinking, okay, well, fine. So far, I don't see how I'm supposed to come up with an equation. All right. So let me point something out. Notice that your mixture, notice this problem. A dietitian needs to mix 10 gallons of 2.5% milk fat. The word of means to multiply. Okay. So that means we're going to be doing some multiplication here. So I need 4% of so many gallons plus 1.5% of 10 minus X gallons to equal 2.5% of the 10 gallons. So in other words, we're going to multiply these together. Now, before we do that, we also need to convert our percentages into decimals. So 4% is going to be 0.04. So 4% of X number of gallons plus 1.5% is 0.015 of 10 minus X gallons has to equal my mixture, which is 0.025 of the 10 gallons. Okay. Now, here's our equation, and now we just solve. So this is 0.04x. Be careful when you multiply. If I multiply by 10, I just move the decimal over one place. So that's going to be 0.15 minus 0.015x equals, and then I'm multiplying by 10, so I just move the decimal over one place. That's going to be 0.25. Okay, now I'm going to combine my like terms, but be careful. So we have, let me pull the calculator back up. Again, I don't know if you're going to see this. Okay, so we have 0.04 minus 0.015. Okay, so that's going to give us 0.025 x plus 0.15 equals 0.25. So we're going to subtract the 0.15 from both sides, and that's going to give us 0.10, right? I should know this, but I always doubt. 1.5. Yep, 0.10. Okay, and then we're going to divide both sides by 0.25. So I'm just going to divide, or I'm sorry, we're going to divide both sides by 0.025. 0.025. And so we get that x is 4. Now, who is x? X is the number of gallons of the 4%. Okay, so we need 4 gallons of the 4% mixture. And so 10 minus 4 is 6. So that means I need the 6 gallons of the 1.5% milk fat. Okay, and then 4 plus 6 is 10. So we know that we're right. So again, it looks more complicated than what it is. It certainly helps to have an explanation, okay? But that's how you handle a mixture problem, okay? All right, last problem, number 7. So this is a uniform motion problem. A plane traveling at 400 miles per hour has a 4-hour head start on a second plane going in the same direction, which has a speed of 800 miles per hour. How far from the departing airport will the second plane overtake the first plane? Okay, my goodness, that is just a whole lot of information, right? All right, now remember, one of our strategies is to draw a picture or use a table. In this case, it's going to benefit us to use a table. Okay. Now, uniform motion refers to, well, let's look at what we have. We have a rate, that's miles per hour, that's a rate. We have time, 4 hours. And then it wants to know how far, which is distance. So they've given us, we know we're looking for distance. They've given us a rate and they've given us time, distance, rate, time. So that should trigger a formula for you. So distance equals rate times time. Okay, this is what I'm going to use for my table. All right, so I'm going to go ahead and create a table real quick. So let's do this. Okay. And then okay. So we have distance let me abbreviate, rate and time. So distance equals rate times time. There's my formula. Now we have two planes. Okay, and I'm going to color code the planes. All right, so I'm going to say that we have plane one, and then we're going to have, oh, I already used, I don't want to use purple. I guess I'll use, well, brown might not show up. And then plane two. Okay, now it says a plane traveling at 400 miles per hour has a 4-hour head start. Okay, so we're going to call this plane one, and I'm going to I'm going to underline this in red. A plane traveling 400 miles per hour has a 4-hour head start on a second plane traveling in the same direction. So this is going to be the brown. So the second plane is going in the same direction, which has a speed of 800 miles per hour. Okay. Now, let's plug in what we know. The first plane is traveling at 400 miles per hour, which is the rate. Okay, so that's 400. Now, the second plane says it's traveling at a speed of 800 miles per hour. That's the rate. Okay, now it says that the first plane has a 4-hour head start over the second plane. So that means if it has a head start, then the second plane is just going to be X because the first plane had that 4-hour head start. Okay, so if this started at time 0, well, 0 plus 4 means that it's already been in the air for 4 hours. Okay, since it had the head start. Okay, now it says how far this means, that we are looking for distance. So how far will the second plane overtake the first? So if the second plane overtakes the first, that means we want to know when they are equal. And I'm sorry about the writing. My hand's a little shaky. Okay, now I have all the information from the problem, but I don't have anything to fill in here for distance. Okay, but what I do know is the fact that plane one and plane two have to equal each other. So that means that plane one oops, sorry, this is where we're going to get our verbal model. Okay, so plane one has to equal plane 2. Now, notice that we don't have anything in here for distance. However, I do know that distance equals rate times time. So if that's the case, then all I'm going to do to fill this in is multiply. So this is going to be 400 times x plus 4. Oh, okay. And then plane 2 is going to be rate times time. Okay, so here's plane 2 is 800x equals plane 1, which is the 400 times x plus 4. And there's your equation. Now this one we had to work through, okay? But that's how you handle these distance problems. And so you always want to look for some word in there that will either tell you that they are going to equal each other, or later you're going to find we're going to work problems where it says that it totals a certain value, which means you're going to end up doing the same thing, except you're going to add these two together and you set it equal to whatever it totals. But in this case, they equal each other. Okay, so here we go. We're going to solve this real quick. So 400 times x is just 400x. 400 times 4 is 1600 equals 800x. Subtract the 400 from both sides. So x is going to equal 4. Now we found the time. That's 4 hours. Now here's the kicker. We're not done. We solved for x, but remember the question is asking how far from the departing airport will it overtake the first plane? So we had to set them equal to each other so that we could find the time. They want the distance. So when is the second plane going to overtake the first? So that means I'm looking at the 800x. So distance equals rate times time. Okay, so this is the distance for plane 2. The rate is 800 miles per hour times 4 hours. Okay, so that means our hours unit cancels, and 800 times 4 is going to give us 3,200 miles. And that is our answer. This one was involved. Okay, but the more you do, the easier this becomes. Okay, so I expect that there are going to be some questions about this. So make sure that you ask, okay? And that's all for the last part 2 of section 1.3. Let me know if you have any questions. Bye-bye.